Hi everyone, welcome to our video on two example problems using implicit differentiation. So the directions were on the previous page. We're going to find dy dx using implicit differentiation. Alright, so to do these problems, it is just going through it term by term, and we just want to remember whenever we do the derivative of a y term, we attach dy dx. Now, a lot of times with these problems, we have to be careful though, because notice here we have a product. Okay, so the minus the xy right there is a product. Okay, so that means I would need to use my product rule. Okay, so we have to be, again, very careful. So right here, double check, make sure you've got everything. Just look at it first before you jump right into doing everything. So notice in this problem, we do have a product. And when we say product, we mean a product of two variable expressions. So not just 6 times x cubed. Yes, that's a product, but it doesn't require the product rule. This one does. X times y, those are two variables multiplied. Okay, so to set up our product rule, let's rewrite it like, let me just go ahead and rewrite the 6x cubed minus the xy plus the y cubed equals 15. So I just wanted to rewrite it. And let us jump into the derivative. And we're going to break it down in words as we go. So in blue, I'm doing the derivative. I have the derivative of this first term would be 18x squared. Okay, so that's just using the power rule. And then I have minus. Now, again, in the parentheses, let's give ourselves plenty of parentheses, or plenty of space in the parentheses. So that parenthesis right there, I'm just making it extra long. And then, well, our product rule tells us, remember the product rule is to take the we could write it. So when it's d dx u times v, it's u prime v times uv, or not times, sorry, u prime v plus uv prime, like that. So that is our product rule. Okay, so on this problem, we can mark these. That's my u and that's my v. Okay, so u prime then, the derivative of x is 1. And then attach the second one, so then just times y, and then plus u, which is just x in this problem, x, times the derivative of y. Well, the derivative of y would be 1, but again, remember, as soon as you take the derivative of y term, attach dy dx. So we'll have dy dx attached just like that. Okay, so that's taking care of that parentheses, and notice I needed those parentheses here. Let me put it in red too, just to really show that last one, because this negative will distribute eventually. Okay, so we took care of the parentheses and then just keep going. All right, now plus the derivative of y cubed would be 3y squared. And again, just make sure to attach dy dx when you do the derivative of a y part. So again, the x, I didn't have to do that. Look at that. So just 18x squared was good. Okay, and then equals the derivative of a constant. The derivative of 15 is still 0. The derivative of any constant is always 0. So again, it's always just use the rules that we still currently have, with just one special exception with the y that we just have to make sure we attach something to. Okay, so we did the derivative, and then now at this point we want to solve for dy dx. Well, first thing I'm going to do is just distribute. So we have 18x squared minus y, and then minus, let's just write this as x dy dx, because I don't really need the 1. 1 times x is x, and then let's attach dy dx still. And then I have plus 3y squared dy dx all equals 0. All right, so because we have multiple dy dx's, let me put those in parentheses, I want these to be on the same side, and I do want them to be on the same side by themselves without any other terms with them. So this 18x squared, I'm going to want to move on over, and this y, I'm going to want to move on over. So I'm going to subtract and add. Now, they usually like the positive one first, so I'm going to do plus y minus 18x squared on the other side. Okay, so it's the same thing, I just put it in a different order. Okay, and then I do have, on my left side, I have the negative x dy dx plus 3y squared dy dx equals that y minus 18x squared. Okay, and then now that I have my dy dx terms together on the same side, and there's no other terms with them, I can now factor. So we always want to wait till those are by themselves like this to factor. And when we do, I'm going to take the dy dx out to the front, and then I'm left with a negative x plus 3y squared, and then still equal to the y minus 18x squared. Okay, and then now I'm just going to show it with a single line. I'm going to just show, hey, I need to divide this over on both sides. I usually leave it blank because of how much time it takes to write, and then I can see what I am dividing and what needs to go on the right. So I know this whole thing would just cancel. So this right here just cancels out when I do the division, and I'm left with my dy dx. So dy dx is now solved for, and we'll put that, let's just put it over here since I ran out of room. So dy dx equals, again, this and the yellow highlight canceled. It's all gone. And I guess let me just go ahead and show that just in case it's confusing. So let me go ahead and show that there, just like that. So I did divide it. So this and the yellow all divided. That's why I have dy dx all by itself now. Equals this whole thing right here, the y minus 18x squared, divided by the negative x plus 3y squared. And that's it. Okay, and depending, they might rearrange some of the letters, like the 3y squared minus x maybe could have gone first. But I'm going to leave it like this and move on. This is it. It's done. Okay, so you can have variations in your answers. All right, so that's the breakdown. That's usually how it goes. All right, let's do one other here where I want to find dy dx. And on this problem, notice instantly it starts with a product. Okay, so here, I'm just going to underline instead of use parentheses instead of rewriting. So there's my u and there's my v. So I notice I do have a product right away. And then the other three terms look fine, or they're easier to deal with. Okay, so I know my product rule. I'm just going to, let's scroll and we can still see both parts of the problem. Okay, so here's my product rule still. And so I'm thinking, all right, u prime. Okay, so the derivative of u would be 2 e to the 2x. And then times just v, which is just y. And then plus my u, which is the e to the 2x, times the derivative of y, which would be 1. And then again, just make sure to attach dy dx as soon as you do the derivative of a y part. Notice I didn't do it to the first part in the product rule because I didn't do a derivative of y yet. Only did it to the x. So only when you're doing the derivative of y something. Okay, and then equals, the derivative of 5x would be just 5. And then plus, the derivative of 16y would be 16. But again, we did a derivative of y, so we would attach dy dx. And then the derivative of minus 2 would be 0 because it's a constant. Okay, so now let's continue to break this down and simplify. Over here, I have 2e to the 2xy plus, now the 1 times e to the 2x we could just say is e to the 2x. And then dy dx equals 5 plus 16 dy dx. All right, and we can see that I have multiple dy dx's again. They're on different sides of the equation. That's okay. I do want them to be together though. So what I'm going to do, and you have your different options here, but I'm going to subtract the 16 dy dx to both sides. Okay, so if we subtract that over, let's go ahead and do two things in one. I think we can handle it. So notice this one doesn't have dy dx in it, the first term. So let's go ahead and just subtract that on over to the other side as well. And then that way, in one big step, we can start, or we could do two things in one in this one big step. So on my left side, that all zeroed out, but I'm still left with the e to the 2x dy dx. And then I have the minus 16 dy dx equals this 5 I didn't do anything to, so it's just there, 5. Those zeroed out, the 16th dy dx minus 16th dy dx, but I still have the minus 2 e to the 2xy. Okay, so that way I did two things in one. I have my dy dx terms together on one side, which now makes it easier to factor. It's ready to go. So the dy dx, I would factor out of both sides there. So dy dx gets factored, and we're left with the e to the 2x minus 16 equals the 5 minus 2e to the 2x y. Okay, and that's typically how these problems go. At this point, I would now divide this expression on over. And when we divide the whole thing. So e to the 2x minus 16, just like that. And then pretty much what you see on the right side is the answer, but make sure it's formal. The dy dx we want to show, dy dx is equal to that right side there, the 5 minus 2e to the 2xy over e to the 2x minus 16. Like that. Okay, so that's how we can break down these implicit differentiation. So they're all very similar, all pretty much similar amount of steps, same strategy. Okay, so just make sure you are using those rules, though, when they need to be applied. Be careful of products. Okay, so products are the easiest ones to miss. Okay, so that's it. Thanks for watching, and I'll see you again next time.